No. So as we just said, what goes inside these brackets? Just numbers or letters? Just those? You could use numbers. We did one last time where I asked you, give me all the names of the states that begin with M. That was a set. That's not neither numbers or letters. Those are words. They can be pictures as well. Yeah, these are objects, or more commonly known as elements. The way this is written out is what method? The roster method or list. What's the other one? So we have the list or roster method, where it's literally just listed out. What's another way of writing them out? Again, if I see everybody look at your notes, well, I'm going to tell you, I'll take out a piece of paper and have a quiz. You guys have to start studying outside of class. That's what school's about, especially if you want to become teachers. Are you going to wait till you get to the classroom and then start reviewing your notes when you talk about? No, of course not. This is where you start learning how to be more mature. Organize yourself. Be prepared. What's the other method? What's that? Yep, very good. Well, did you see that in your notes? The set building method. What this method does is it gives us a formula to create this list. So what would be the formula for this list? Yeah, such that. Very good, very good. X is a natural number. And what else? Natural numbers are all the counting numbers. It goes on to infinity. Look at them. So X is less than or equal to 5. This tells me everything I need to know. It's natural numbers, so they're integers, only the positive ones, where X is less than or equal to 5. So it's 1, 2, 3, 4, 5. We will have a quiz like this next time. Sometime in the next class, we will have a quiz. I'll give you 5 of these type of questions. All right. What else did we talk about last time? What's that? What are equal sets? When are sets equal? If and only if what? That's simply a condition. If and only if what? Again, I don't want you guys reading out of your notes. I can do that. I gave them to you. I need you guys to do this outside of class. So when are two sets equal? Yeah, but now put all that stuff together. Think about it. When are two sets equal? Let's try something you guys never try. Let's look at your notes. So if you're sitting there doing nothing, flip back and look at your notes. I don't want anybody just wasting their time sitting here doing nothing. What is it? What's the definition?
Wasn't class, so I don't have it.
What'd you say?
No, yeah.
So this one means is an element of, or you can say belongs to. Two sets are equal if and only if each element in the first set belongs is also an element in the second set. They have to have the same elements and they have the same number of elements. What else did we talk about last time? And what does that tree diagram tell us? Tells us how many different combinations of elements we can make. Okay, what else we talk about?
The one-to-one correspondence.
One-to-one correspondence. What does that tell us? What does that tell us? What good is that?
That each element of A maps to the element.
And if it does that, what does it create? Equivalent set. Now, I see all of y'all take notes. Okay, great. But they're only as good as you use them at home. Highlight your notes. Get different color highlighters. For definitions, use one color. For examples, use another. For any other, I mean, use color code your notes so you don't waste your time just looking for everything. If it was highlighted, you'd have much easier time finding what you're looking for. But that entails you doing more work than just writing them in class. Because if you think about it, what's the point of writing notes in class? Why even do it? If you're not going to review it, why even do it? And remember, this is only the first level course you're taking. This is a freshman level course. If you want to be teachers, you're going to have to take higher level courses where they're going to expect you to know everything you've taken before. Did we do any set operations? Did we define any terms in there? What's that? Which ones? What is De Morgan's law? This is very sad. What is De Morgan's law? There are actually two of them. Well, all this stuff deals with logic. I mean, this entire course, since it's a math course, it deals with logic. Does that ring a bell? As I told you, everything we deal with logic deals with mathematics. This is the we call nowadays the distributive property. And you should have in your notes already. So, let's move on. Again, you're wasting your own time if you're writing them down and never looking at them. You're wasting your time and paper and pencil. So far, we've talked about these. Let's hope you can get those. What do they represent? The what? The or an and, which one's which? Okay, let's go for U and N. Which one's which? Or is which one? The U or the N? This is the or. You're right. This is the same one that matches with the V. And this one is the and. That's the same one that matches with the arrow up. What's the difference between these two? Because what's the difference between these two types of symbols? No, I'm talking about how are these different? Since they're both ors, how are they different? What do B, P, and Q represent? Okay, the capital letters, minuscule letters, but what does that mean? What is that? So what's the difference?
One's for a set and one's for a variable.
No, they're both variables. But you're right for the first one. Which one defines a set?
Four letters.
Yeah, these deal with sets. Deal with statements. These deal with statements. And these deal with sets. Where we compare elements of sets or the truth of statements. So since we're dealing with sets, we're doing other set operations. Let's look at what does this mean? How would you read that? Very, very good. Set A or set B. That's literally what it says. But here's how you'd really read it. What about the set A and set B? Since set A and set B are made up of elements, we're going to look at here, we're going to look at an element belongs to set A or set B. if it's in set A or set B, what does that look like? Everybody familiar with Venn diagrams? With sets, it's easier to deal with Venn diagrams. What is a Venn diagram? What does it consist of? The circles. Where you look at, if you have two sets, sets A and set B, they belong in something called the universe. The universe of all sets in that realm. Set A or B, how would you represent that in Venn diagrams? Is it just where they overlap? Because remember, it belongs in set A, or it could be in set B. That's what it looks like. It's everything. It's everything in A or B. Because if these are all the even numbers, these are all the odd numbers, and you're asked to pick a number, well, guess what? It's either going to be odd or even, so you're going to win no matter what. So the or statement combines everything in set A and everything in set B. How is that different from this statement? Every element belongs to set A and set B. There's the universe. Here's set A, and here's set B. If it belongs to both set A and set B, where is it going to be shaded? Where they overlap, right? The U and the N help you memorize what it's doing. The U here, the or statement, stands for union. For example, like uniting. If you unite something, what happens? You put them both together. After the Civil War, North and South were united. We became the United States. So union means in both A and B. That's everything shaded in. The N stands for intersection. On a road, when you get to a road, what is this place here called? What's it called? called the intersection. Why is it called the intersection? Because this left and right traffic meets the up and down traffic. It's the intersection. It's where both sets of traffic are in the same place. This is where they overlap. That's why that's the intersection. So far, so good. Disjoint sets. What do you think those are? What do you think a disjoint set is?
Like that A doesn't belong to the B. No?
Yes, but can you be more clear about it? How would I draw it in a Venn diagram?
They're most likely separate.
Let's see, in mathematics, they are separated. It's not most likely, it's they definitely are. Those are disjoint, where they have nothing in common. If two sets are disjoint, can you do the union of the two? Yeah, because it's everything in A and everything in B. You can pick anything from here or here. You have everything you can pick from. How about the other one? Is there an intersection? No. If there's no intersection, what do we call that? Remember, A and B are sets. What's the resulting set? What's the answer? Do you have anything? So there's nothing in common with these two, right? So we call that an empty set, which they have nothing in common. There are two ways we can represent that. If we're dealing with set notation, just brackets with nothing in the middle. Bless you. It's brackets with nothing in the middle. Or the zero with a line through it. That represents an empty set. You cannot write this. Because the empty set, if it's inside these brackets, is an answer. So this is no longer empty. If you're going to do empty, it's either going to be this or this, not both. All right, let's look at some examples. Here are the sets. A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6. This is example 8. What is that going to equal? Yeah, well, this says is where do they overlap? They overlap at 3 and 4. Make sense? How about the union of the two? So it would be what? Right. And if they overlap, only write it once. This next set. A is 0, 2, 4, 6. And B is 1, 3, 5, 7, ... What is that answer? What's that? What does that represent? It's got a name. Empty set. It's an empty set. Because there's no overlapping between these even integers and these odd integers. What would the union be? How would you write that as a set builder notation? X such that X is greater than or equal to 0. Okay. Set A are the even numbers again. Set B are all the numbers. What would those two answers be? There's no words that I put all odd numbers. We have to use symbols here. Okay, so what does that represent? Is that defined anywhere in there? Because they're overlapping where? All the even numbers, right? What do all the even numbers represent? A. So that's A. Yes. No, because A itself is a definition of the set. Good question. If I'm listing the elements, then I have to put in brackets. But remember, the list of elements is defined by A. Good question. Very good question. How about the next one? Very good. Because it's both of these put together, which is this one. Let's look at the formal definitions. The set intersection of two sets A and B written A and B is the set of all elements in A and B. And using set builder notation, we would do this. So the set intersection of two sets A and B is written A intersect B is a set of all elements in both A and B. It's written this way. A and B is equal to the set of X such that X is an element of A and X is an element of set B. There's a formal definition of it. This in set the second definition. Set union of two sets A and B, blah, blah, blah. Written A union B is the set of all elements in A or B. So that would be A union B is equal to the set of all X's such that X belongs to A or X belongs to B. But my fat head's not in the way. So far, so good. Now, all of this relates to the truth tables we've had in the past too. Remember, since this symbol means and, it's the and operation. This is the or operation. So we can create truth tables with those guys too. Let's look at some more examples. Find each of the following if A is equal to the set 1, 2, 3, 4, 5, 6. The first one. There's the second one. There's the third one. And there's the fourth one. What's the first one? Very good. Why would it be an empty set? Exactly. Because A has nothing in common with nothing. How about the next one? Maybe what? No. It would be A. Because this is the union, you combine them both. So all of A and nothing is all of A. This is where it comes in, this also for its mathematics. The and symbol eventually became multiplication rules, and the or symbol became addition. A times 0, 0. A plus 0, A. How about this one? 0 times 0, 0 plus 0, 0. So again, all this stuff, this is where mathematics came from. So that's our union and intersection. We're combining sets. Let's look at the set differences. When we talk about that, we're talking about, we have to introduce something called the complement. In the earlier chapters, we called this the knot. So if we had set A, okay, let's look at this. If the universe were all the numbers from 1 to 10, and A was simply the even numbers, then the complement of A would be all the odd numbers. we can either write it like this, or we can write it like this. This is typically how we do it. This represents not A. How did we talk about it when we dealt with sentences? What's that? What was the negation symbol we used in section 1? The squiggly thing, yeah. When we're dealing with statements, we dealt with not P. But now we're dealing with sets. Now we're dealing with not P. The reason I'm saying this one here by itself is if I had this. Oh. That's the set difference. What it's saying is this. All elements in set B not in set A. Well, I'm missing here. This is the important one. And not in set. So here's the set builder notation for it. B minus A, let me get on top. B minus A is the set of all x's such that X is an element of B and X is not an element of A. Here's another example. So that's the definition of set difference. Okay, for all of these, set A is defined as D, E, F. Set B is A, B, C, D, E, F. Set C is A, B, C. And set D, C, D, E, F. So how would you read this? What is it asking for? Everything in set A, not in set B. So is there anything in this set that's not in here?
There's nothing to say, hey, that's not in blue.
Because it's not set B, set A. Is there anything in set A that's not in here? If it was the other way, was A minus C. We'll get to that in a second. Is there anything in A that's not in here? D, E, F, right? Is there anything in B that's not in here? Well, they both have A, B, C, so that's that. Right. Right. Because the first one went from something small to something big. So whatever's in here that's not in here, man, there's nothing. There's just, I used up all three of these right there. But this one, I have all of these. I get rid of these. Because think of it the same way we're doing here. So C is A, B, and C, right? So I cancel those. So I cancel those. What do I have left? Again, this is mathematics. You're subtracting now. C minus B. Because what we're looking for when in these subtractions is what's left in this first element, if anything. If everything in this first element cancels, there's nothing left. So basically what this is saying is whatever I have here, I take away these, what do I have left? That's what the concept of subtraction is all about. C minus D, yeah. So everything in C, I have A, B, and C. I get rid of whatever is overlapping. They both have a C, right? What do I have left here? You only list what's left in the first element. And the last one. Does it matter what the universal set is? Yes.
So you know how you said whichever is left is higher, baby?
And which one? B? Yeah.
Well,
Because now in this one, A is D, E, F. I get rid of A, B, C. So do I get from this set, I get rid of A, B, C. What do I have left? A, D, E, F. That's what that is. Because this operation is removing from this first set. Since they have nothing in common, I don't remove anything, so I'm left with that. C minus B. This C is ABC. What can I get rid of? I can get rid of any of these letters if they exist in this set. C, so I have left AB. Or in, that's BC, I'm sorry, backwards. So it's whatever's left in the first set. Once you get rid of the second set, whatever's left in the first set, that's your answer. How about if I had D minus A? Yeah. Because D is C, D, E, F. A is D, E, F. I get rid of D, E, F. I'm left with a C. You easiest way, if you want to, you could list them all out. C, D, E, F minus D, E, F. Just remove what you have. Whatever is left in this first one is your answer. That's what subtraction is all about. Five minus 3. 1, 2, 3, 4, 5. 1 minus 1, 2, 3. I get rid of 1. I get rid of 2. I get rid of 3. What do I have left? 2. Yeah, that's where the whole concept's coming in. Example 4. Is grouping important? Yes.
B was taken away from A, but answer would be C.
B minus A.
Yeah.
So B is are all these. I get rid of these. A, B, C. Well, you can put C then, yeah. Since this is what defined, yes. Yeah, so what we're saying is this. B minus A is equal to C. Yeah, because we defined all the sets up here first. Okay. Is it important when two different set operations are involved? Is grouping important when two different set operations is involved? Let's see what this means. What this means is something like this. If we had A intersect B union C, A intersect B union C. Those look like the same statements, don't they? But now, once I introduce parentheses, that's grouping. Does it change the answer? Again, in mathematics, you can't just tell me yes or no. You have to tell me why. What is your proof? How would you prove this? You would have to first define some sets. Let's say A, B, C. That's set A. Set B, let's make those C, D. And set C, D, E, F. You'd have to do both sides and see if they come up with the same answer. Bless you. So again, this is a math class. You can never just spit out an answer yes or no without thinking about it. Especially when the first chapter talks about logic and reasoning. You have to think it through first. Let's prove this. Was A intersect B, union C, A intersect B, union C. All right, so what do I do here first? I have to do both sides separately. A intersect B. What is there? Yeah, so this is A, B, C intersect CD unioned with D, E, F. So the intersection of this first set is what? Yeah, it's just C, isn't it? Where they have in common is just C. So now I union it with D, E, F. That gives me C, D, E, F. That's this first side. Now let's look at the second side. We have A, B, C intersect with C, D, union D, E, F. All I did was list what's in each one of these sets. So inside the brackets, I union these two, which gives me what? C, D, E, F. Very good. Now I do the intersection. Where do they intersect? Are they equal? No. So the order is important if you have different signs. Does it relate to mathematics we do now? Well, let's see. 3 times 2 plus 4. 3, this is in parentheses, times 2 plus 4. I'm saying that A is 3, B is 2, C is 4. Are they equal? 3 times 2 is 6 plus 4 is 10. 2 plus 4 is 6. 3 times 6 is 18. No, they're not equal. Because remember, the and symbol is multiplication, the or symbol is addition. Example 5. Here's A, here's B, and there's my universe. Use the set notation to describe the shaded portion. So look at this first one. What's happening here is we have all of A, all of B minus this part. So what we have is all of A, all of B, minus this part. And that's where they overlap. And there are other ways you can do it as well. A, B, C. We have two of them. Whenever you have multiple disjoint ones, that's an or statement. But how are A and B related? What does that define? The first one is where A and B do what? They overlap or they, yeah, so it's A intersect B. That's this shaded region. Then we have this other side here, which is where B intersects C. Since it's your answer is in either of those, that's where it's union. These take, again, this is why it's a logic and reasoning section. There's a union. So our pictures, this is A, B, C. What's the only part we can't use in that picture? Where these two do what? Where they well, not overlap. Overlap is right there. Where B and C are combined. So anywhere where B and C overlap and combine, we can't use. So we take that away from our A set. So we start off with A and we take away wherever B and C exist. A, B, C. Okay, so we look at here, we know we have all of the A and B, A and C minus the B parts. So how do we put that in this in a statement? We first start off with the A union C, because that's both of these. Now we got to take away B. But if we take away B, we take away that as well. So what we have to do now is we have to put this part back. And what is that part? That part is where A, B, and C all overlap. All right. Now let's work backwards. In a survey of high school backgrounds of 110 college students, the following information is known. 25 took physics in high school. 45 took biology. 48 took math. 10 took physics and math. 8 took biology and math. 6 took physics and biology. And 5 took all 3. Okay, it sounds like a lot of information. But what we have to do is we have to create a Venn diagram where we have all 3 of these. You have, what do we have? We have physics, biology, and math. And when we finish it, we add up all the numbers, and what should it equal? 110. Because if we add up all these already, that's more than 110. So so where do we start? Where's the most logical place to start in these kind of puzzles? Start in the middle. So we know that 5 took all 3. Now, how is that going to help us? Well, we know that 6 students took physics and biology. So this football here is the physics and biology. But we have 5 in there already. So how many left over do we have? 8 took biology and math. So this football has to be 8. But we have 5 taken care of. So we have 3 left. Because again, where these overlap, biology and math has to be 8. Biology and physics has to be 6. 10 took physics and math. So this one goes 5. 48 took math. So we have 5, 10. Math is this whole circle here. So we have 13 taken care of already. So 48 minus 13 is 35. Took math only. Because yes, these people took math, these people took math, these people, and all these. 45 took biology. Biology is here. So it's 5, 6, 7, 8, 9. So 45 minus 9 is 36. 5, 10, 11 from 25, 14. Now, if we count all of these numbers, we have 36 plus 14 is what? 50. 50 plus 35, 85, 90, 95, 96, 97, 98, 99. We're supposed to have 110. So that means there are 11 that didn't do any of those. That's why we have to know the number in the universe. It looks difficult because there's a lot of this writing, but when you start in the middle and start breaking up, it's super easy. Actually, these are logic questions they have on law school exams. And people freak out. This just takes a better part of 2 seconds. Okay, the last thing we're going to talk about are the Cartesian products. They're also called cross products. So let's say we have 2 sets. All the Cartesian cross product says is the combination, since if I had A cross B, that's every element in the first group multiplies to everybody in the second, or become pairs. So I have 1A, 1B, 1C, then 2A, 2B, 2C, and then 3A, 3B, 3C. That's all it tells you, and that's our set. It's just now, since this came first in this product, it's got to go first in all of these pairs. Whatever comes. So even if I had B cross B, I would have ABC times ABC. So I would have what? AA, AB, AC, then BC, then have BA, BB, BC, CA, CB, CC. That's all the Cartesian product is, the cross product. Pretty straightforward. And you know how many answers you should get. Since this group had 3, this group had 3, I have to have 9 answers. If I had 3 and 2, I'd have how many? 6. So that's why they call it the cross product, because I can multiply these. That's how many I'm supposed to come up with. All right, that's it for chapter 2. So do the homework and get ready to take the test. All right, have a great, safe weekend, everybody. Again, from day 1.